Alright, this is part 2 of our lesson, and now that we've learned a little bit more about horizontal asymptotes and we've learned about holes in graphs, we can go ahead and do some examples. So here we have number 1, and we're going to start by factoring it. So we have f of x equals x minus 3 times x plus 1 over x plus 2 times x plus 1. So notice that we can reduce it. We can cancel the x plus 1's, and there are no other x plus 1's, so we know there's going to be a hole, and that hole would be at x equals negative 1. That's the number that would make that factor 0. And so our reduced form is just f of x equals x minus 3 over x plus 2. And we're going to use the reduced form to find just about everything. It's much easier. So for the y-intercept, let's plug in 0 for x, and we get 0 minus 3 over 0 plus 2. So we get negative 3 halves. So 0, negative 3 halves. For the x-intercept, we're going to plug in 0 for y, and we know that basically what that does is it just sets the numerator equal to 0, and we get x equals 3. So we have the point 3, 0. For the hole, we already know that its x-coordinate is negative 1, and to find its y-coordinate, just substitute negative 1 into the reduced function. So we have negative 1 minus 3 over negative 1 plus 2, and that's negative 4. So the hole is at negative 1, negative 4. And then for the asymptotes, looking at the reduced form to get the vertical asymptote, look at what makes the denominator 0, and that would be x equals negative 2. And then for the horizontal asymptote, let's use our shortcuts. So notice that the degree of the top and the degree of the bottom is the same. Whether you look at the original, which was x squared over x squared, or if you look at the reduced one, x to the first over x to the first, they're the same. And because they're the same, it's not top heavy and it's not bottom heavy, we take the ratio of the leading coefficients. And the leading coefficients are 1 and 1. So 1 over 1 is 1. So the horizontal asymptote is y equals 1. Okay, for the limits, we were going to do the limit as, we can say limit of f of x, or you can call it y. Limit of y as x approaches negative 2 from the left, and the limit of f of x, or y, as x approaches negative 2 from the right. And we also have the limit of f of x as x approaches infinity, and that one goes along with our horizontal asymptote of 1, so that's going to be 1. And the limit of f of x as x approaches negative infinity is also going to be 1. So let's finish the other two limits. So pick a number that's a little bit to the left of negative 2, like negative 2.1, and let's plug it into our reduced form. So let me clean that up just a little bit. Okay, so plugging into here, negative 2.1 minus 3 is negative, and negative 2.1 plus 2 is a tiny, tiny negative, little more than, or a little less than 0. Negative over negative is positive, so this one is going to be positive infinity. And then for something to the right of, or a little bit more than negative 2, we can use negative 1.9. So negative 1.9 minus 3 is negative. Negative 1.9 plus 2 is positive, tiny positive. So negative over a tiny positive is going to be negative, so this one's going to be negative infinity. So we're going to put it all together and make our graph. So how about the asymptotes? X equals negative 2, y equals 1, and how about the points to plot? 0, negative 3 halves is our y-intercept, 3, 0 is our x-intercept, negative 1, negative 4 is a hole, so let's just make that an open circle. So based on those 3 points, we can tell that the graph is going to do something like this. And then on the other side, we need an extra point, because you have to have at least 1 point for each section of your graph. So what if we use negative 3? Plug that into the function. Negative 3 minus 3 over negative 3 plus 2 is going to be negative 6 over negative 1, so that's 6. So we can plot the point negative 3, 6, and then just making sure to do what the asymptotes or excuse me, what the limits are telling you to do is going to go kind of like that. Okay, so that's number 1. Number 2, let's go through the same process. So we're going to factor, and we get f of x equals x minus 1 times x plus 1 over x minus 1 times x minus 3. So we're going to cancel the x minus 1s, and there are no other x minus 1s, so we do have a hole there. The hole is going to be at x equals 1. So I'm going to go ahead and write that down. Okay, now for the y-intercept, and once again I want to say use the reduced form that we just found for everything. So for the y-intercept, plug in 0 for x, and we get 0, comma, negative 1/3. For the x-intercept, plug in 0 for y, so you're setting the numerator equal to 0, you get negative 1. So that's going to be the point negative 1, 0. For the hole, we already know it's at x equals 1, so 1 plus 1 over 1 minus 3, that's plugging it into the reduced form. We get 2 over negative 2, so we get negative 1. For the asymptotes, look at the reduced form, look at what makes the denominator 0, and you get your vertical asymptote x equals 3. And for the horizontal asymptote, just like problem number 1, this one is not top heavy and it's not bottom heavy, it's equal, and the leading coefficients are 1, so we just get y equals 1. And then for the limits, we want the limit of f of x as x approaches 3 from the left, and the limit of f of x as x approaches 3 from the right, and we want the limit of f of x as x approaches infinity, and we want the limit of f of x as x approaches negative infinity. And those two last limits are going to be 1, just like our horizontal asymptote. So for something a little bit to the left of 3, we could use 2.9. So 2.9 plus 1 over 2.9 minus 3, that's going to be positive over negative. So that one's heading toward negative infinity. Remember, the denominator is really, really close to 0. That's why the whole fraction is close to infinity. And then for something more than 3, we could use 3.1. So 3.1 plus 1 over 3.1 minus 3 is going to be positive over positive, so that one is heading toward positive infinity. So let's graph everything. Vertical asymptote, x equals 3. Horizontal asymptote, y equals 1. We have the point 0, negative 1/3. We have the point negative 1, 0, and we have a hole at 1, negative 1. So you can tell from those 3 points, if you just follow them, it goes like this. And that also agrees with what the limits are telling us to do. We're supposed to go down to negative infinity when we're to the left of 3. And then on the other side, for my extra point, I'm going to use x equals 4, plug it into the reduced function, and we get 5 over 1, so we get 5. 4, 5, plot that point, and then we can go ahead and follow the limits, and we get the other side of the graph. Okay, let's do one more. And there's something special about this one, and I think it's going to help it to go faster actually. So if you're getting weary, I think this one is not going to take 4 minutes. So we're going to start out the same way by factoring. X squared minus 9 factors into x plus 3 times x minus 3, and then this is over x plus 3. So we can cancel the x plus 3's. That means there's a hole there. There's no other x plus 3 left. There's a hole at negative 3. But look at all we have left. All we have is f of x equals x minus 3. And you know what that is? That's just a line with a slope of 1 and a y-intercept of negative 3. So that should make things easier on us. We can even plot that point to start with, 0, negative 3. Let's find the y-coordinate of the hole. So f of negative 3 is negative 3 minus 3, that's negative 6. So the y-coordinate of the hole is negative 6. So we have the point negative 3, negative 6. Make that an open circle. And here's our line with a slope of 1. Sorry, I didn't make that super straight at first. Okay, The x-intercept, when y is 0, we're going to get 3, so we get 3, 0. And what about the asymptotes? Well, because our reduced form did not have a denominator, well, I guess you could say the denominator is 1, but there's no numbers that make the denominator 0. There's no vertical asymptote. And notice if we use our shortcuts that the degree of the top is 2 and the degree of the bottom is 1. Or if you look at the reduced form, the degree of the top is 1 and the degree of the bottom is 0. It's top heavy, so there's no horizontal asymptote. So this has no asymptotes. Now that doesn't mean it has no limits. You always do the limit as x approaches infinity. What's happening to the y values as x approaches infinity? They're also approaching infinity. And then we have the limit as x approaches negative infinity, and we see the y values are going to negative infinity. So this is just the equation of a line with a hole in it. Okay, so your assignment is to do these 4 problems: factoring and reducing, finding the intercepts, the holes, if they have any, the asymptotes, the limits, and drawing the graph. Number 4 is a little different. So you're not going to get a whole lot of information from some of these parts, but what you can do is plot extra points to help you figure out what the graph looks like. Thanks, everybody.